Now here we have a problem. This is a problem of deflection of beams. Problem number 9.1. What does he say here? Determine the maximum deflection of the simply supported beam carrying a hydraulic cylinder. There is a hydraulic cylinder here. See, there is a hydraulic cylinder in the machine used to press bushings into a casting. You have a casting here, and then you have got a bushing here. This bushing has to be pressed into it. Anyway, you have to apply a force downwards over here. Okay. As shown in the figure below, the force exerted during the pressing operation is 15 kilonewtons. Here how much? 15 kilonewton force is acting downwards. Okay. The beam is rectangular, 25 centimeter thick and 100 mm high. So he has given me the depth as how much? This is 25 centimeter and the height is how much? 100. Okay, and made of an SAE steel, that is the Society of Automotive Engineers steel. He has given us the value of E. The value of E is also there. So you can see here, this is supported here and this is supported here. If I want to draw the beam somewhat looks like this. Okay. So now when there is a force acting downwards, there is equal and opposite reaction which is acting upward over here. Okay, that is exactly in the middle. How much is that? That is also exactly 15 kilonewton. Okay. Now you have got a support reaction over here because the beam has to support it. You have a support reaction here. You have a support reaction here. Basically, what is happening now when this is pushing down, the beam will automatically get bent like this. It's bending upwards. Okay, here he wants me to find out this value of y. Okay, so now what equation I will use? I will use the equation of deflection of beams for a point load on a simply supported beam. Okay, so now what is the formula? The formula is what? Y is equal to WLQ by 48 EI. From where did we get this formula? We get this formula from the derivation. We derived it actually. It is in another video. So now you need to remember this formula if you want to solve this problem. Okay. So now here E is given in the problem. I have to calculate. What is the value of I? See, I is what? I is nothing but B dq by 12. Okay. B is how much? B is 25 into 10 cube divided by 12. How much is this value? We have to calculate it. 1 minute, let me calculate. $25 multiplied by 100 mm, is it? No, sorry, see, I write it 10 cube, it is 100 cube. 100 to the power of 3 divided by 12. So I have this one as 2083333.33 millimeter to the power of 4. Okay, it's a long number because to the power of 4 is there. So I is done. Now the value of E is given. The value of E is how much? 200 into 10 cube megapascal. So what is the L? L is 1.6 meters. So please convert this one into millimeters. L will be equal to how much? 1.6 into meters to centimeters is multiplied by 100 and then to millimeter is another 10. That is another 10 cube millimeter. Now let us take this one and substitute over here. Again for kilonewton, please make it into Newton. 15 into 10 cube multiplied by L is how much? 1.6 into 10 cube, this whole cube. Please be careful. Don't put 6 here. Divided by 48 multiplied by E is how much? E is 200 into 10 cube multiplied by I. The value of I is here. You can even change it to engineering units so that the word will become very small. Anyway, let me write it 20833.33. Okay. So this is the value. So let us see 15 multiplied by 10 to the power of 3 multiplied by 1.6 into 10 cube whole cube divided by, when I do it, I get an answer of 2.97 millimeter. This is the value of Y maximum. Okay, this is what I get. So you have to be very careful while making the calculations. Even if you miss one zero, your answer will land somewhere.